How are you doing, Alrocar?
I'm great. I feel a little bit greener than usual. I don't know why.
This is because of the this is because the color of
I know.
of our slides. It's making you look a little bit green around the edges. It feels like you're maybe sick. You've
It
eaten
reminds me
something.
like the Simpsons, like when he's on the Homer is on the factory. Uh, anyway,
So yeah, we are going to talk about OpenTelemetry today, and we are going to uh, instrument an application and hopefully explain how to do that and how to use OpenTelemetry for instrumentation, for observability, to set up alerts. We are going to use Grafana, we're going to use Tinybird, and we're going to use OpenTelemetry and some templates and so on. So I think it should be interesting. Um, I thought we would start with a very, very quick intro to what OpenTelemetry is, like a super fast one, like maybe a lot of people already know, but you never know. And because we do these things to be useful, we will do a very, very quick intro, and then it becomes apparent how these things work as we set them up. So once we start setting it up, I think some of the things we're going to talk about are going to become super easy. So do you mind going to the next slide?
yeah.
So essentially what OpenTelemetry is an open source standard for collecting and exporting telemetry data. And it has like three main constructs, which are metrics, logs, and traces, which we're going to talk about. It has default implementations for different language SDKs that you can use to instrument your application. So if you're working on Python, you have a Python SDK, you can very easily start instrumenting applications to capture metrics, logs, and traces. Or if you have JavaScript or Go or whatever, there are multiple SDKs to do that. And one of the key things, and one of I think the biggest reasons that OpenTelemetry has become successful, is that it's vendor agnostic. It doesn't care about what is the final destination for your data. It basically gives you all of the tools to capture it, and it has a framework framework to build exporters, and a set of exporters that are already there and actively maintained that you can use to send data to multiple vendors or systems. That makes it really easy to move from one vendor to another if you're unhappy. So it avoids vendor lock-in, which is a very important problem and thing to think about when you have huge amounts of data. So that's what OpenTelemetry is in a nutshell. If you go to the next one, there's it's like a very simple diagram of how this could look like. There's a component called the collector, which is a binary that runs in a machine, and it's the one that is collecting all of this metrics, logs, or traces from either background processes that are monitoring a machine, for instance, or applications that are monitoring, that you instrument and you want to track and see how it behaves, and potentially from other collectors that are sort of forwarding data on to the OpenTelemetry collector. It does this in a format called OTLP. It is called the OpenTelemetry protocol. And then with the collector, you can use one of the many exporters to send it to a final data store. Obviously, I put Tinybird at the top there, but there's many vendors you can send. You can send it to Datadog, or you can send it to ClickHouse, or you can send it to Grafana. You can send it to many different systems and vendors to then exploit that data. There are some that are directly OTLP compatible, that accept OTLP, and those don't necessarily require an exporter. So we'll explain specifically what is it we're going to set up a bit later, but that's the gist of how this normally looks. So if you want to go to the next one, we'll just introduce what each thing is. It's all very simple to understand. Metrics specifically is sort of numeric measurements that you collect over time. This could be things like CPU usage, or request rate, or error count, memory, whatever. And then the purpose of those is to monitor trends and spot anomalies and set alerts that can help you not just understand what's going on, but also react to what's going on if there are problems and so on. That's metrics. Logs is, as you can imagine, text records of events that are going on. It's what happened specifically at this moment in time, which can be like this user logged in, or this payment failed, or it can be something about this request to this third party failed, or this is being retried, or whatever. And then the purpose is essentially to provide context so that you can follow things along better and you can understand what might be going on and if you have problems. And the last one is traces, which is essentially a way to track a request along its journey. So for instance, if you want to track a single API call from the front end to the back end to the database and back, you can do that with traces. So you can better diagnose potential bottlenecks or see what's going on with the latency in a distributed system and so on. So that's essentially it. So OpenTelemetry, open source standard for observability, vendor agnostic, metrics, logs, and traces. So let's over to you to explain a little bit what we're doing today.
Yes. So I'm going to jump directly into start building something. So the thing is, we have here this landing we built this week, in which we explain how all these pieces fit together. Not only that, but like a super quick start. Okay, so 3 steps on how to deploy the necessary schemas for the data, how to instrument an application, and how to configure an OpenTelemetry collector, and finally how to connect to an observability tool. Today we're going to use Grafana. Okay, and this is the schema. Basically, we're going to have a set of applications. I found out OpenTelemetry has OpenTelemetry demo, which is good for this purpose because, well, we'll see in a few minutes. Then we're going to send traces, logs, metrics through an OpenTelemetry collector using the OpenTelemetry exporter of Tinybird. So we're gonna have a project in Tinybird, which underneath uses ClickHouse to store the data and to run queries, etc. And finally, this week we released ClickHouse compatible HTTP interface. So that enables like a bunch of use cases. One of them is BI, and another of them is observability. So we're going to use today Grafana, and we'll see how everything integrates together. So
yeah,
I'm going to start in the terminal. And first thing I'm going to do is, let me see, I'm going to make this bigger. I'm going to clone the OpenTelemetry demo repository, and I'm going to open it as well. So this is the official demo they have, and many vendors use it to showcase how they integrate with OpenTelemetry. So eventually we will be there because basically it's what we're going to do today. We're going to showcase how we integrate with the full ecosystem.
Yeah.
And I'm going to start it. There is a OpenTelemetry demo. There is a bunch of things. I'm going to explain it a little bit, but first I'm going to start it because this takes a bit of time. And let me show you what we have in here. So basically we have a huge Docker compose file with many different services. Each one in one language. There is a service in Go, there is a service in Ruby, there is a service in Python, C#, C++, Next.js. I mean, there is like the complete ecosystem put in here.
That's funny.
And there is a bunch of services. This is like an e-commerce store. So there is one service for accounting, for ads, for recommendation, for the cart service, for the checkout service, for changing currencies, for sending notifications by email. There is a bunch of them, and there is then the OpenTelemetry collector already in place. There is another container with the OpenTelemetry collector. We will use this first, and then we can use hosted one. And there is also a Grafana, and there is other tools, Prometheus, Jaeger, blah, blah, blah. So let me see if this works. Okay. So this is the application. It's an e-commerce to buy
telescopes.
Basically.
Yeah, that's a bit obscure.
Yeah. So basically, you have like typical actions, your cart, you have a checkout button, etc. And the thing is, we're gonna start seeing how these traces are generated.
Being generated as you click around, right?
That's it. So one way to visualize them is like this. Let me get the checkout service. And as you can see, when you do a checkout from the front end, there is like a bunch of things going on. This is on purpose. I mean, it doesn't make sense to make an application like this, probably, or yes, I don't know. But this is on purpose to showcase, okay, what are the different spans in a trace? What is the request journey you mentioned before? Okay, and we could go like to any of the different services. We have them here, and we could look, for instance, for the checkout project, and we could take a look at how it's instrumented and so on. But let me go first, like end to end, and then we can go like deeper.
So what you were looking at in that sort of diagram was a single request, right?
Yes, that's the operation I did, the checkout. Basically, when I clicked on the I'm gonna always forget to do this. Okay. And what this is going to do, first I have to log in. Let me log in like this. I'm going to use Europe West 2. I'm going to create a new workspace, empty workspace. And
awesome.
I will run this. Okay, it already downloaded something. I'm going to remove Tinybird and try again. And I'm going to do it again because I removed.
You deleted the the credentials. No worries. It's the demo effect.
TV login, Europe West. Now I'm gonna choose the OTel
one, right?
This one.
That you created earlier.
And now we can deploy like this. Okay. So the thing is,
it's worth showing that. I was going to say, let's show what's like the data sources and
the thing is, we have, if you look at the command, this is a GitHub repository. So basically, we have a GitHub repository with all the resources necessary. We have the data sources for logs, for traces, and several ones for metrics. And we have a few endpoints, utility endpoints. They are not necessary, indeed, but we have them. And some materialized view we will see later. And the thing is, when you run this command, it clones the repository locally, downloads all the resources, and deploys them, in this case, to the cloud version of Tinybird. We could use Tinybird local, but for now, I'm going to use the cloud version. And that's it. So with this in place, we can connect telemetry with Tinybird, and we need to do
essentially essentially what you've created in Tinybird is the schemas that are required for the Tinybird Open Telemetry exporter to be able to send data into Tinybird, and it will contain exactly the fields and so on that
they are
required
already
for each one.
they are already like predefined. So for instance, for traces, we have this schema. With a timestamp, trace ID, span ID, and then we have the attributes, resource attributes. These are the important fields: the service name, etc. Same thing for logs. As you can see, the schemas, I mean, they are not super complicated, but if you have them like already prepared and you just have to run one command, it's more convenient than having to write yourself. So according to this diagram, we already have here the schemas. So we need to connect the application to Tinybird using the OpenTelemetry exporter. So that's what we're going to do now. And I have here above this snippet, and we're going to use this directly. So here in the OpenTelemetry demo, we have a container with the OpenTelemetry collector. Let me make this a little bit bigger, and let me close this. And this has already a configuration, okay? The configuration is in this variable. Let me look for it. Wait. Okay, this variable, which is in a typical environment variables file. And it's this one, okay? So this one. So it's already configured because there are some backends already configured and etc. Okay, so the structure of this file is it looks like complex, but it is not. So basically, what you have is you configure which are your endpoints to get data according to the OTLP protocol. You configure two, one for HTTP, one for gRPC. And then these are like pre-made receivers. Like, for instance, this one, it's a binary that can collect data from Nginx. This one from Postgres. This one from Redis, etc. Okay? So this is fine as it is. And then we have, let me check. We have the processors, which is, okay, when the collector receives data, you want to do something with the data. Usually, you configure the batch one. It's like a buffer. Okay, let's buffer for 5 seconds and then flash the data to the exporters. And finally, you have like exporters, which is the destination where you want to send the data. And here we have Jaeger, which is this application where we were looking at the traces. This is Jaeger. Prometheus, which is configured in Grafana, and OpenSearch, which is for logs. If you look at the exporters, there are like 3 different tools.
Receiving the data, right?
One for traces, one for metrics, and one for logs.
Very interesting.
This is very typical in OpenTelemetry. It's like there are like tens of tools to do like the same thing or very different things, but on the same ecosystem. So in this case, we're going to configure the Tinybird exporter, which is like unites like the 3 components. We are going to have logs, metrics, and traces. So instead of having these 3 tools, we're going to have one.
Just one.
So I'm going to take this. If you look at the default configuration, it's similar. It's receivers, processors, which we recommend like batching, and finally the exporter. So I'm going to copy this exporter configuration like this. I'm going to paste it here. Wait.
Yeah, we lost your screen.
Sorry, it was the screensaver. Can you see my screen now? Yes.
Yeah, it's coming back.
So this is, let me show you one thing, because this comes from OpenTelemetry country, I guess. Yes. There is this repository in the OpenTelemetry organization, which is
the official contributions
from official vendors or partners. And we have here the Tinybird one. So basically, this is open source. We have the help of one of the maintainers of the project, which has been very helpful, to be honest. And basically, this has all the logic to gather data from the collector and send it to Tinybird using the events API, which it is an HTTP API
endpoint.
So with this in mind, we have to configure a couple of variables. One for the events API endpoint in Tinybird, and one for the Workspace token. I'm gonna get this in a minute. This is basic. I think it's not necessary having like the batching before, but anyway, I'm gonna leave it like that. And then we have a configuration of what we want to do with the metrics, logs, and traces. And basically is just send them to the data sources we already have deployed.
Exactly, the ones we saw earlier.
Yeah, we already had traces, logs, and several metrics data sources in the workspace. That's it.
Awesome.
And I'm gonna grab the host and the token from the workspace. This workspace. I have here an iterations option. This is the host.
Yep.
And I'm gonna put it in the environment. And this is the token.
Yep.
And for the token, I'm gonna get this one. Or I can get it from here. Usually, we can get like a specific token we have with append scopes.
Yeah, that's part of the project. When you deploy the project, it creates this token, right?
Yes, but I'm gonna get the admin one just in case. So with this, we already have the exporter for Tinybird, and then we have the last part I didn't mention, which is this. It's the configuration of the service. This is like, so for traces, we have the OTLP receiver, we have different processors, and we have where do you want to send the data? So we're gonna add Tinybird in here, here, and here.
Yeah. So essentially, you first have to declare the configuration of the exporter, and then you have to specifically say use it, basically.
That's it. Maybe you want to use just for logs, I don't know, or maybe you don't want metrics because you already have Prometheus or whatever.
Whatever.
So let me check. I'm not missing anything. Services, I think it's already done. So now I'm going to do something, which is I'm going to load the environment variables. I'm going to make sure they are there. For instance, this one. Okay. And then I'm going to restart everything. Probably it's not necessary to restart everything, but maybe I can
just to
restart.
Just to be clear, so we're using here the demo that contains all of these things, but you could just set up the which I think you plan to do later, the collector, configure what you want to send it to, and that's it. So here it's just running a lot of things because it's a demo, but we don't need to run all of this all the time.
Next start. So we now start everything. And I'm gonna print the logs of the hotel collector to see if everything is right. Missing Tinybird endpoint. Invalid configuration. Missing Tinybird endpoint. Let me check if everything was right. Oh, okay. I know what I'm missing. So I declare the environment variables in here, but I then need to pass them to the hotel collector.
Oh, I see.
I'm going to try to stop just the hotel collector and start it. Unset environment variable, Tinybird token. I'm going to try to restart, and otherwise I stop and start everything again. Docker compose restart.
Did you you did the sourcing of the endpoint, but it should pick that up when it starts, no?
Yes, I think this is right, and this is right. Let me stop and start everything, and let me check that error makes sense. Maybe we are getting data already. Let me check data sources. No, we're not. And this is the right container, yes. Maybe, well, let's try. If it doesn't work, I might wipe all the images, because I think I might have like previous images or something from a previous run. And I'm going to open another one and see when this starts. Okay, now it's working.
Awesome.
So stopping and starting the container didn't work. So let me check the. Okay, so we are not having logs.
Oh, great.
This is
and this data is coming from the generator that you had running, right?
Yes, that's it.
Great.
So with this in place, we need like the last step, which is, okay, we already connected the applications to Tinybird, and then we need to connect it to some visualization tool, okay? So for that, we're going to use the ClickHouse HTTP interface, which their settings are in here. So it's this URL, and the password is the admin token, actually. And for that to work, I'm going to open the local Grafana we have. Grafana. And usually what you do is you install the ClickHouse data source. And I think I have to configure so it works. Let me do it quickly. So this is the Grafana container, and we have here a section in which you can tell, okay, install the Grafana ClickHouse data source. It's called like this. And then I want this to be like Grafana data persistent, because maybe we need to like restart several times Grafana. And we need permissions to install stuff like here. And I'm going to...
all of this because you're running sort of a local image of Grafana.
Yes.
If we were using Grafana Cloud, we would just simply have to connect to Tinybird, right?
Yes. The thing is, when we do like the end-to-end thing, we can use like OpenTelemetry collector I have deployed on the internet, and then we can connect to Grafana Cloud. Because having everything in local, it's like more convenient, like using Grafana also locally.
Yeah.
I'm going to do it again. Grafana, okay, I have to configure the volumes, Grafana data, and I think it's like this. Stop. In the meanwhile, one thing I'm going to do is one thing I've been doing actually with telemetry data is, if you look at the schemas, they are like a bit complicated. I mean, because there are like different columns, like event attributes, span attributes, scope attributes that are like a dictionary. So basically, they are meant like that, so you can add anything in there, and you don't have to constantly iterate the schemas. You need another metric, you add it to the span attribute or whatever. And one thing I'm using a lot is explorations, which is, okay, since this is too complicated for a starter, let's try to get help from an LLM to understand what the project looks like, the data, and so on, because then we're going to make some questions to the LLM to generate SQLs and so on. So I'm going to tell analyze the project and tell me what it's about. So I'm going to start doing this while we restart. Start. And what this is going to do is it's going to go through every different data source. It's going to grab some data, and it's going to detect
what type of service,
the services, the different metrics, etc. So then when I have to ask like more detailed questions, like, okay, build me a query to calculate the spike on CPU, it's going to do it better.
Yeah, it already knows this.
So basically, it nailed it. It detected this is for an e-commerce application, monitoring the different services, the different tables, the endpoints, etc. Okay, so that's fine for now.
Pretty smart explorations.
So, okay, this is up and running now. So let's go to Grafana again, and let's try to add the ClickHouse plugin. Sometimes it takes a little bit of time to load in here, but now it's fine. So I'm gonna go to the settings, integrations. I'm gonna copy this. So this is compatible with the ClickHouse HTTP interface.
Yep.
And I just have to put in here like the HTTP port. I'm gonna say this is HTTP, this is a secure connection, and then I have to configure ClickHouse username. I can put anything because we don't use it. The only thing it's needed is this password or token. And with this in place, we've connected Grafana to ClickHouse to Tinybird, okay? And there is one interesting thing in here, especially for this kind of demos. There is this OpenTelemetry dashboard, and I'm going to import it right away.
Yep.
And we can take a look at it. Because this is right away visualizing the data we're ingesting from the telemetry we're ingesting from the applications via the telemetry collector to Tinybird and then visualizing in Grafana.
Yeah.
So if we look at each panel, basically what we're doing is using the ClickHouse data source and running an SQL. In some cases, it uses like the typical Grafana macros. So when you use the dates or whatever, or if you have parameters, that the query is like rendered properly. And I think the most interesting part to me is this one, the traces, the trace visualization, because I'm gonna grab the checkout service, and if I open this one, we can see we have the exact same view we had in Jaeger.
So Jaeger, yeah.
In this case, in Jaeger, we had the origin was the front end because I made like a request myself. In this case, we have like the origin is the load generator, but from there, everything is like the same request journey. And if you remember, we enable a couple of feature flags in here. So this is the time to understand a couple of use cases for this. So on one hand, we have this recommendation cache failure. And I'm gonna look for this in the code. Let me see. Recommendation cache. So basically, when this flag is enabled, it creates a span with an attribute that sets the cache hit to false. Okay.
Right.
And when it's not enabled, there is a cache hit to true. So the thing is, we should be able to see this just looking at the traces. Let me see if there is some case for this. I'm going to wipe this. And okay, order by duration. So if I click on this, we can see, and well, this is in the get product list function. Okay.
Yeah.
So looking at the trace, let me look for get product list function. I'm not seeing it. Get product list. What is it?
Is it maybe product catalog or within product catalog? Or I don't know if those are all expanded. See, yeah, if you go to get product, the actual URL is get product list, no? If you go to product catalog, sorry, like the name of the function to the right, no, the next one. So
here,
is it not get product list, the name of the method? Or is get product?
A little bit smaller. Okay, maybe this one is not the right one. Let me look for another one. Here. Get product list. No. This one. It's wait because it should be there.
Maybe we do the opposite. Let's find the product catalog and see if there's in the code, see if there's.
It should be. Let me review a couple of more traces. 1 second. I'm going to open 4 or 5 of them because sometimes I think the generator needs like a few minutes to start generating traces that make sense.
Right.
Wait, let me try this. View panel. Get list. No. this one. I don't get what's going on, to be honest. Let me see. Okay, there are more traces now. View. No. Then I'm going to try the other use case to see if I can see anything. Anyway, the thing about this is the way you use this is as follow. Basically, what you have here, this is an example, okay? But what you try to find here is like usually performance problem, okay? You have this this function that has many different function and services calls. And whenever you find the, for instance, in this panel, the performance is worse than usual. For instance, in this case, there are some requests that take 180 milliseconds, while there are others that take 20 milliseconds. So this is when you try to correlate, okay, why this one took 180 seconds. So in this case, you have here like a list of traces, but you could have, actually, let me check the query. Okay, they are ordered by duration. So you can get like the slower requests to the second service. And then you analyze the trace. So when clicking on the trace ID here, basically you can see the duration of each one of the calls. It can be a function call on the same API, or it can be a call to a different API, wherever. Every span, which is called, every of these lines is a span of the trace, already labeled with the proper function, etc., and you have the duration. So in this case, for instance, we had 120 milliseconds to get prepare order items, blah blah blah. And here you have more informations. We can in this case we can get what's going on. Maybe sometimes it can be, okay, it's actually you are processing like a lot of items, so that would be one cause. That was what I wanted to show with the
I understand.
And you can also compare with another trace. For instance, you can get one trace that is
it's very fast, and
with another one that it's not. So for instance, if I get one that takes 20 milliseconds and I open in a new tab, okay, and I take the one that takes a little bit more of time, this one, we can put them one together
side by side.
Let me go back. View. I clicked to edit. So, and you can understand, okay, this one took like 70 milliseconds, this one took 121, and you can compare both. Okay, sorry, you can compare like if you can find some correlation. Okay. And other times it's not just about the content or what you're logging in the span, but what you want to do is to trace to correlate, sorry, with other metrics. So that's why you usually have here other panels like memory, like CPU, like whatever. Okay, more related to the hardware where the queries are running and so on. So this is one thing. There is also an interesting thing about OpenTelemetry is whenever you log a span, every log you put in the code can be correlated to the trace. So for instance, if we have here this span, we can go and check the logs. And for that, I have to change something. Sorry, I have to enable a couple of things here. I have to say this is the name of the workspace.
Can you make it a little bit big? Can you make it a little bit bigger? Because there you go.
I have to configure the logs for the ClickHouse data source to OTel, plus click this button so it automatically guesses all the columns.
Yeah.
And the same thing for metrics. So with this, we can correlate traces
between
to
metrics.
logs. And
logs, yeah.
Back. Let me check.
Maybe you have to do it in the newer.
OTel. No, this should work. Let me check it out again. Few logs. Okay, this is it.
That's great.
These are the full logs for
that specific
a given trace.
Yeah.
And in this case, we're seeing an error in here, for instance, payment request failed, blah blah blah.
Yeah.
And
you did set it to fail all the payments, I think, in the generator.
Yeah, that's right. Actually, I wanted to, let me check. Yes, one thing I wanted to do is like the opposite. So given that we have all the logs, and whenever a payment fails, we know we are logging something. Let me look for it. If I look for the payment failure log, payment failure. So whenever a payment fails, we log this. So we can do like the opposite route. We can go and go to the logs
and the message
payment request failed.
Mm-hmm.
Let me check. So this is filtering, of course, all the logs that matches this string,
mm-hmm.
and from here we can correlate the trace. We can take a look in the same way we had before. So we can go from trace to logs and from logs to traces.
So essentially, you've got like a 360 view of everything that's going on, both from the point of view of the request and whatever, where is it, what is it doing in every method and so on, how long is it taking, what are the parameters that it's carrying, etc. But at the same time, if there are logs specifically being written or spat out, let's say, you can then see it from both angles.
That's it. So usually the way you think on this on production is you have like your main dashboard where you have errors, you have metrics, and you have traces. You put them all together because most of the times you want to correlate the three things. You want to correlate the errors with the metrics, and then understand what is the trace of the request, what's going on, and then go more in detail with the logs. So that's like the whole thing.
Very cool.
And we have talked about logs and about metrics and about traces, and a small sneak peek about metrics. The thing is, we have 3 or 4 different tables for metrics. We have these, which are like counters, like the typical count the number of requests for a service.
Yeah.
We have this, which is like a value that can go from an interval, for instance, CPU usage that goes from 0 to 100. And those two are the ones that are more used. You use these to build time series, to have counters, to have everything. And you can build alerts on top of these two. These other two are less used, okay? So one thing we can do is, since we've had in the OpenTelemetry collector, OTel collector, where is it? Here. we have a bunch of receivers. We have receivers for Nginx. We have receivers for Postgres. These are like instrumenting these components and sending a lot of metrics, but we don't know which metrics are they. So for that kind of exploration is very useful using an LLM. So what I usually do is I ask explorations to analyze the different or the unique metrics available. And this is going to go through the metrics tables. We have 4. It's going to take what are the different metric names, and it's going to tell you, okay, you can. This is everything you can analyze from your system. So, for instance, we have here, on one hand, we have metrics we send from the applications, which usually are counters. Okay, how many requests are you having in the front end? How many items per card or whatever? Okay. But then you have like typical Docker container metrics. I think this is okay. Docker container metrics from the system you're running, in this case Go, how many memory is using the Go microservice, whatever.
Everything.
For every different microservice. This application is nice because since every part of the stack is built on a different language, you can have like many different instrumentation metrics and understand how they work and so on.
That's awesome.
So for instance, one thing we could ask is, okay, basically this is everything we have. We have 44 system metrics, 62 runtime metrics, infrastructure, things from Kafka, from the database, from HTTP, blah, blah, blah. And you can ask for, I don't know.
Time series, maybe?
Yeah, create a time series for memory usage of Python microservices. I don't know if this, I don't think this nailed it. Series name, that's not correct. So look what service names use Python. Let's give it another try. I'm in the time series. I think I should be in the chat. What service names use Python in the metrics tables? I think it's the recommendation one. Let me look for it. There is a recommendation service in here. Yes, this is Python.
Yeah.
Okay, the recommendation. Yes. So basically, this is making its own way to look for service names which have some metric with name Python, and it has found a couple of them: load generator and the recommendation service, which is the one we're looking for.
Very smart.
But service name. Okay. Let me see what. Okay. So it tried to find like process runtime memory usage, but didn't find any data. So then it used the CPython, which is like the interpreter from Python.
And it did find it. Huh?
Let me see if it can create a time series with that. I don't know if it's able to gather the context necessary to build this time series, but let's give it a try. No, it's not doing it. Yeah. Runtime memory usage.
You can change you can retry from the chat in the time series as well.
Yes. I think I can change it here.
Yeah.
No. Average value. No, it was the date. I mean, there is one date that I think it doesn't have proper data. So this is it.
Yeah. Is it? There you go. There you go.
Okay. So one thing we can do, and I've done these days, is okay. Once you have some sort of metric you want to analyze, you can have like a quick sense of how it looks like in explorations, but then you can build like the SQL for Grafana.
Mm-hmm.
So if I ask here, let me ask, build SQL like this to use in the Grafana ClickHouse data source. So
it was going to create the query for you so you can paste in Grafana, right?
And hopefully it's able to embed like the Grafana macros and so on.
Mm-hmm.
Maybe.
While it's calculating this, Javier Revillas, who's watching the stream, was asking, can you try visualizing something like the per minute error rate for one of the services or the request rate? So we can try that after this.
Yes. Let's
or start a new exploration, maybe.
Can you for one of the services for the payment?
Change it to the time series. I don't know, maybe it changes automatically, but
okay. So let's check this. Wait. I think I've messed. Having two explorations at the same time is
it's a bug. Yeah, we need to report that to Julia and team.
Text in error file severity text from OTel logs group by service name. It's not working. Let's try to do first because I think this is one-off. I think time series are usually one-off.
Mm-hmm.
And probably the chat can do it better. Calculate the error rate per minute of the payment service. Let's see if this can generate the SQL. Okay, so now you can look like the difference here. Mm-hmm. I think it is not inspecting the actual data because it went to the OTel logs and it tried to filter by error and fatal. But here it's like, okay, let's see the different services names.
Yeah.
Let's examine the different severity text, etc. Okay.
Yep.
Now there is the time range, etc. So basically, if we look at the query, it makes sense. We don't have errors because I think the application is not using error for errors. It's using warn. I don't know why.
Right.
But we can assume warns are errors. Okay.
Okay.
So this is basically it. So I think, I tried to create this Grafana thing. I don't know if it would work or not. I'm going to give it a second try. I'm going to tell to use the Grafana time macros. We write the SQL to use the Grafana time macros. And in the meanwhile, I'm going to create like a new panel in our dashboard here. add a new visualization, and we select Grafana ClickHouse, and we run the query. We have something, but this is not connected to the, oh, actually, no, it is not connected to the filters indeed. It's running everything all the time. Let me check. No, I think it's not doing it. Okay, this looks better. Let me check. Okay. No, it didn't do it. Okay, anyway. I think it's the same query. But the thing is, so just to wrap up this part. So what we went through was going through an application, sending to OpenTelemetry, storing Tinybird, connect to Grafana, okay? And inside Grafana, once you have the ClickHouse data source, it's just a matter of writing the right SQL. And you can use, as an utility, you can use explorations, okay? When you are familiar already, usually you are familiar with your metrics because it's you who's writing the metrics. So you don't usually need this, but for a starter, it's like a good place to
start. If you're new to a project, and the great thing about explorations is that you can pretty quickly get a sense of what's happening, what are the main services, and what might be the main problems going on, etc.
That's it. So I think we can spend like maybe 15 minutes in trying to run this, but in the cloud, like.
Okay. Just like you would set it up basically for a service.
Yeah. OpenTelemetry collector in the cloud, Grafana cloud, Tinybird cloud. And we can do that pretty quickly because basically I have already prepared. So actually I'm going to keep it running. Let's keep it running. So I'm going to use fly.io, which is like very simple and convenient. And the simplest way to run an OpenTelemetry collector is like using their Docker image. They have an OpenTelemetry collector contrib, which is the ones that have the partner exporters.
Yeah,
you can use it.
So the OpenTelemetry, the Tinybird one's already in the official contrib,
and many others. And we just write the configuration. We can just copy paste it, the one we had in the website. Remember, you first describe the receivers, then you batch a little bit, 1 second is fine, and then you configure the Tinybird exporter.
Yeah, just as we saw before.
Same thing. We have an endpoint and a token. This is the important part, and everything else is going to be automatically connected to the proper data sources.
Yeah.
And this is the pipeline definition. So the only thing I have to do is to take the token, this one, and I'm going to put it in here. And
are you going to stop the other stuff, or just so that you can then see some?
Let's stop it.
Yeah.
And we can go to the fly and deploy. I'm not sure if the environment variables are set. Otherwise, I'm going to do it manually also. So this is something to mention while this deploys. OpenTelemetry deployment. So basically you deploy the OpenTelemetry collector in 3 ways, which is no collector, nobody does this, which is basically coupling your application with some backend. Usually no one does this. The other option is you deploy the OpenTelemetry collector together your application, like in the same server or whatever. Sometimes that's convenient or necessary. And the usual way is you have your applications and you have one or more collectors somewhere else. You can have a load balancer or not, depending on the scale. And from there, you can go crazy and do like a mix of things, etc. Okay, but that's like the main way of deploying, and that's what we are basically doing. This is going to be like a separate service, like the gateway mode. It's going to be on a separate host, and then we're gonna have our application in another place. So let me see if this deployed. Okay, this is fine. Secrets. I'm going to add the secret just in case. Make this one. The token. Okay. Okay. And now we're gonna do Grafana Cloud. Grafana, this one. Let me see if I have the instance running because I haven't used it for a while.
Yeah. The first, so if you're not using it, it just goes to sleep, basically.
Yes. Fine. Let me check. Okay, it's running. So, okay, we already have the ClickHouse data source. That's fine. The only thing I'm going to change is the password. Let me look for it. This one. And I'm going to use this. So with this in place, we have now connected this Grafana Cloud instance to the data we had in Tinybird. Dashboards. So this is what we had. I stopped it, so we're gonna stop seeing data soon. But this is what we've been generating. Okay.
Yeah.
And now I'm going to connect it to the Web Analytics Starter Kit. So, in case you don't know, people looking at the stream, we have this template, which is a template to track visits to your website. I'm going to deploy it locally, and I'm going to connect it to the OpenTelemetry collector. Okay, remember this schema. So instead of using the OpenTelemetry demo, we're going to use Web Analytics Starter Kit, and same thing, instrumented with OpenTelemetry, Tinybird, Grafana. Actually, I already have it because this is going. Otherwise, this is going to take a little bit of time. And the way I did it was a little bit hacky because let me look. Okay, this is the dashboard. This is an XJS application. And I created these files, front-end tracer, instrumentation, middleware, blah, blah, blah. And you might say, what is all this? I don't know. I do know, but I wanted to show the hack. So the hack will basically, given that you have an OpenTelemetry demo with services in many languages, which are already instrumented, what you did is, okay, cursor, do the exact same thing that instruments this front-end application, apply to my application. So if you look at this telemetry folder, there is front-end tracer, instrumentation.
Yeah.
Blah, blah.
Did you copy those over, or did you just tell Cursor, hey, here's
yeah, I told, okay, do the very same thing, because the thing is with OpenTelemetry is there is quite a bit of boilerplate and dependencies and so on. If you look at this, well, let's go to the Web Analytics Starter Kit. There are like a few things because you want metrics for the user agent, blah, blah, blah. And you need the attributes to have a specific format. And you want to track clicks. And I mean, there is like many, which is fine because everything is like isolated and you can decide what you want to instrument and whatever. But the important part in here is all these files are just to set up the OpenTelemetry. This is and auto-instrumenting both the APIs and the Next.js middleware. Okay.
So when you talk about auto-instrumenting, what does it give you by default?
By default, I think it gives you resources, how the page loads, which different resources load on each page load and the duration and so on. Also clicks. So you can basically build the user journey on your front end, like the user click this exact element and this other one, and then this other one, all tied to the same session. Plus many other things, like the typical for Node, for instance, you have like the classical metrics, CPU, memory, blah, blah, blah. And then you go like manual. Like, okay, I want to track this request journey from front-end to backend. And then we can see like an example, okay, I have prepared. So the only thing I have to change here, as you can see in like this boilerplate, we need to set the OpenTelemetry collector, let's say, or exporter, sorry, endpoint. So I'm gonna do it. Well, actually, I don't need to do it because it's already here. Okay, and that's fine. So,
so this is going to be sending. The collector is running in flight. You're going to be running this locally. So when you run it, it's going to be sending it in OTLP format directly to the collector in flight.
Hopefully.
And then the collector in fly is going to forward it on to Tinybird, basically.
So let's give it a try. Hotel dashboard. And this is the application. Okay. And let's check. So by default, this has a service name, which is Tinybird Analytics Dashboard. Let me go to Tinybird. If we go to explorations, I'm going to start a new one. And here, select from OTel Traces, order by. Okay, so I have configured with this service name, so all the traces from the Web Analytics Starter Kit can be filtered by it. And as you can see, by default, I just loaded the page. So we have, and by the way, I'm just instrumenting traces, not metrics, not logs for this specific case. But well, we have like typical documents and resources that are being loaded when you load the page. So if we look at the span attributes, we can see the different JavaScripts being loaded. Okay.
Yeah. Yeah.
How much time does
Each one take
and so on. And finally, and with this we can close. Let me look, because I asked to add like a couple of examples on how to send a trace from the application. To be honest, I don't know where is it. So I'm going to go to the application and look for this. Okay. So just to simplify it, I added a couple of buttons to force doing some action on the website.
Yeah.
I'm going to click this one. And what this did, so this is how you instrument, for instance, in this case, web application. Okay.
Yeah.
So you have your trace object from the OpenTelemetry library. You put in a name for the trace, and you start sending spans. In this case, I just made a click. These are attributes. This is open for extension. This is what I told at the beginning. So this is like the span attributes. You can put anything in here.
Yeah.
And that's basically it. So it's like different trace with different actions. Okay. And then we have a separate one, which is I'm going to save this for later. Nested span. So this simulates the process of having a trace with different spans.
Yeah.
And let me see if I can see anything here. No, this is happening in the backend. Okay. I'm going to copy this. And we have the nested span example. Basically same thing, but not the same thing, because on one hand, you start and span with a name, same thing as before, but then you have here the concept of context, which is the way that OpenTelemetry provides to correlate different spans to the same trace ID. This is implemented in the standard, and it goes through the transport, through HTTP headers or whatever. So in this case, this is running like in the same application, but if you had like different microservices, it doesn't matter. You always have access to that context, and from there, you can grab like the parent ID,
trace ID.
Trace ID. So everything is like tied together. Okay. So if we go back to Grafana, hopefully we can filter in Grafana Cloud. I'm going to refresh. We should have like a new service, because we are starting tracing our application. And from here, I'm going to filter, for instance, the couple of traces I ran manually. This is one. And this was a very simple one. These are the attributes present, the name, blah, 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 the button click. And then we have the other one, which is like a
bit more sophisticated.
A nested one. And here it is.
Yeah.
So this is pretty much it. Like the full end-to-end thingy. So this is running, I mean, the application is running locally, but since the only configuration it has is the collector environment variable, you can just deploy this to Vercel or whatever, set the environment variable, and you're
start instrumenting.
Yeah.
Very cool. Good stuff. Thank you very much, Alrocar. This was a long one, so thanks for the effort. Can you do one thing quickly? Can you open a browser window and go to Tinybird.co /builds. This is just to remind everybody that we are setting all of these live sessions. They're available on YouTube, so you can see them. If you didn't catch them live, you can catch any other offline. So, and if you want to know about new ones, you can subscribe. So, yeah, that's you don't have to enter your email or anything. Just subscribe to the YouTube channel. Anything else from you, Alrocar? I like your hat, your cap. I know the underlying reason why you're wearing it, but I won't say it publicly.
Other way.
Shout out to your hairdresser. All right, man. Thank you very much, and yeah, see you in the next one. Thanks, everybody.